Welcome to Hartman Math. Today we're going to look at properties of logarithms. This is lesson 3.3. We're going to begin with the change of base formula. Previously we looked at evaluating things like log base 2 of 8. Remembering that a log is an exponent essentially, so 2 to what power is 8. We could do that, figured out that was 3. However, it was log base 2 of 7. 2 to what power is 7. They don't have this, we can't write both sides as powers of the same base, so we wouldn't really be able to do that by that technique. So we could use the change of base formula, which we have here with base b. Usually you're going to use one of these two right here. Base 10 is probably the most common one, but in case we could use this one as well. So for example, if it was log base a of x or log base 2 of 7, the numerator is the log of the argument. The denominator is the log of the base. So if it was log base 2 of 7, we'd say log 7 divided by log 2. Now this one just over here says, if someone stole the log button off your calculator, we could still do the same thing by doing the natural log of 7 divided by the natural log of 2, and you would get the same answer. So let's try that. Example number 1. Use the change of base to approximate log base 3 of 30. So if we were going to use this one here, we'd say turn into a fraction on top, log of the argument divided by log of the base. So it's log 30 divided by log 3. Just a reminder, if we don't write the base, we're talking about base 10. So that would be about 3.096. Go ahead and pause the video here while you consider the checkpoint and see if you can evaluate log base pi of 0.03225 round to the nearest thousandth. So we could do it with the common logs here. It's shown with the natural logs. It wouldn't matter. You'll get the same answer, negative 3.000. Properties of logarithms. So these kind of connect back to some of the properties that we have for exponents. So we have a product property for logarithms, which says that if we have the log base a, I'm going to kind of ignore here, of a product, u times v, we can split that up into the sum of the logs of both factors. So log of this factor plus log of the second factor. It also works for natural logs. The quotient property, log of a fraction is equal to log numerator minus log denominator. Now notice this is not log u divided by log v. That's something different. That takes us back to the change of base that we were just looking at. This is the one single log of a quotient or a fraction. Splits up log numerator minus log denominator. This is kind of similar to doing this with exponent properties, where you would do something like 3 to the 7th divided by 3 squared. You would subtract the exponents. 3 to the 2nd times 3 to the 7th. You'd add the exponents. Now the power property doesn't really connect back to one of your exponent properties. This one says the log base a of an argument u that's raised to a power. We can rewrite the exponent out in front as a multiplier, n times log base a of u. So we just move the exponent out in front. All right, the first thing we're going to look at is using these log properties is to see if we can expand or condense some expressions. Hartman's rule, though, is as you're writing out your steps, you're only allowed one property per step. So you can't do both the quotient and the power property all at once. One property per step. So example number 3, use the log properties to write each logarithm in terms of natural log of 2 and the natural log of 5. And our problem is to work on the natural log of 10. So our initial thought is, how does 10 as an argument connect to these arguments, 2 and 5, you might instantly recognize it's the product. So we could think of this as being the natural log of 2 times 5. And since this is a product, we could use the product property to split it up and say that's the natural log of 2 plus the natural log of 5. That's our product property. All right, part B, the natural log of 5/8. Clearly the 5 we recognize. How are we getting the 8? It's just a few of these 2's, right? It's 2 to a power. Remember, logarithm is an exponent, so exponents are very important in these things. So 2 to the 3rd power. So that's one way we can look at writing that. And once we are there, we have the natural log of a fraction or quotient. So we can immediately break that up with the quotient property, natural log numerator minus natural log denominator. And one last step, remember, one step at a time. This one's fine, but this is not in terms of the natural log of 2. We can have this exponent here, so we're going to take the exponent, put it out in front. That's the power property. So there's our final answer. We've got the natural log of 5 minus 3 of these natural log of 2's. Checkpoint. This time we're going to look for logarithms in terms of log, common log, log base 10, we don't write the 10, log of 3, and log of 5. We're trying to do this for log of 9 over 125. Go ahead and pause the video here until you're done. So we got the quotient property. We can separate there. We can rewrite 9 as 3 to the 2nd. 125 is 5 to the 3rd. Power property, power property. All I did in the last step was I did the power property twice, but I did not do 2 different properties, so I did not break my own rule. Quotient property, did some simplifying, and then the power property. Example number 5, kind of like what we have been doing there, expanding logarithmic expressions is to use the properties to kind of rewrite them. Oftentimes it's going to be to rewrite them and break them up into more pieces. I don't think that's what's going to happen here in part A, but a helpful hint, if you are doing any expanding, make sure you do the power property last. So quotient or product would have to come before that. But I don't see any product, no multiplication going on, there's no division going on, so I think we can go right to the product, the power property. We probably need to write this as a power. So rewrite it from root form into exponential form. 5th root means x to the 1/5 power. Now we can use the power property by taking the 1/5, moving it out in front as a multiplier, so that our final answer is 1/5 times the natural log of x. Part B, log of, so we got a common log in this case, log base 10 of a fraction. So let's start there. If we're going to do the power property, we're going to do that last. So I see the fraction right off the bat. Let's do the quotient property. Next thing we should look for, is there any multiplication going on? Oftentimes it does get skipped. Let's not skip it. We've got multiplication going on over here. The other thing that's going on is this is also following a minus sign. So the minus applies to all of this. So if we do separate this, I think we should, going to need to use parentheses. So there is a product. It's y squared times z. So we need to separate that with the product property. Product property, we separated, we use the parentheses. In the last step, we should probably distribute the minus, also take care of the exponent. Doing that last for the power property, move the 2 out in front of that particular log. Not the whole expression, just that particular log. All right, checkpoint. Go ahead and expand this expression using those properties and the hints. Pause the video here. All right, our expression a little bit challenging in this case, but we do see the fraction right off the bat, so let's begin with the quotient property. There's the start. We don't need the parentheses here, but this is a product, so we'll separate that out, but there's nothing in front, so the parentheses aren't really doing anything. Back here, this the square root means 1/2 power, so transforming into exponential form out of root form. So x squared plus 1 to the 1/2. Didn't need that, didn't need that. We'll move the 1/2 in front, but over here, we always want to simplify. Always simplify. Log base 3 of 3, that's one of our log properties, or just say 3 to what power is 3, that just becomes 1. Always simplify. So 1 plus that term minus that term. This does have to stay in parentheses to say we are taking log base 3 of that entire expression. Example 6, to reverse, what if we want to condense? And condense essentially means to smash it together. So as far as a hint goes, since condensing is the opposite of expanding, the hint is also the opposite. So instead of doing the power property last, our hint is now to do the power property first. So any multipliers out in front of our logs go up as exponents. So that's our first step. Next thing we recognize, we've got addition. So that's going to represent the product property. Smash it together, one single log, natural log, of factor times factor. Natural log of x cubed y squared. Part B, this one's pretty challenging. So I need to kind of pause, think about some things at different times. Log m minus 2 log of the quantity n minus 3 plus 1/2 of the log of p. And the issue here probably is the order that things are going on in. It's probably best if we have all the minus stuff go at the end. So you may want to rewrite it in that format where all the positive logs are at the front and all the negative logs are in the back. Once we've done that, we're good here. This one here, the 1/2 is going to move up as an exponent. Same thing here with the 2. Keep the minus. The 2 is going to move up as the exponent. So we did the power property and we regrouped. When you do that, when you have now this time we only have one negative log, but if we had multiple negative logs, we would want to group those together with one set of parentheses. So minus and then all of this. So now the addition, we could smash that together with the product property. And p to the 1/2 just means the square root of p. And the last thing is we have log minus log. That's why if there were a bunch of negatives, we'd want to group them together. Is to turn this, use the quotient property, say log of numerator, denominator. That's all for today. I'll see you next time.